Hey everyone, Sean here for Lambda School, and in this video we're going to be taking a look at Unix sockets. So first off, again, what are Unix sockets? Some of you might have had the chance to look at a particular API called Socket.io. If you have, you'll know that that is a simple to use and really useful API that allows you to easily set up and configure sorts of like messaging applications, because the sockets API that they provide you allows you to send messages between multiple clients and kind of broadcast messages out and things like that, which is pretty cool. We're going to be essentially working with sockets at a lower level in the web server project. So in this particular project, you guys will be using a lower level socket API in order to send messages between a server and a client. So I guess in this particular case, we need to answer the question of what a socket is in this context. So not so much in like a high level API context like with Socket.io, but basically in Unix land, in low level C programming land. So first off, in order to answer the question of what are sockets in that particular context, you guys might have heard the term, or basically the philosophy, that in Unix everything is a file. And if you haven't, well, now you have. But basically the idea in Unix is that anytime we want to perform any sort of I/O between multiple processes, we use an intermediary kind of shared file in order to actually do that. As you can see here in this illustration, we might have two processes, a P1 and a P2, and both of those might have, if they wanted to perform any sort of like inter-process communication or perform any sort of I/O between both processes, they would essentially do that in Unix using a shared intermediary file that both processes would have read and write access to. And both of them would have read and write access to this shared file through a thing called a file descriptor. So basically the file descriptor is the handle through which they can then read and write into the shared file. And again, since both of these processes will have access to this shared file, that shared intermediary file is thus able to basically facilitate communication between P1 and P2. So that's a little bit about the philosophy of how everything in Unix is kind of facilitated through a file. There's a lot more to it than that, of course, but we're obviously just scratching the surface. And no, this isn't the only way inter-process communication can be performed. There are other ways as well, such as, you are also able to set up inter-process communication directly from a process P1 into P2. You don't necessarily need to do it through an intermediate file, as we're seeing here, but this is kind of the most common way that it's actually handled. And again, file descriptors, which we just saw, are basically nothing more than integer values associated with an open file. So for example, if you looked at some C code like this, where we initialized fp here, which is a file pointer or like a file handle, basically the same thing as a file descriptor using fopen with write access, you could then go and print out that fp pointer and it would basically just be an integer. And the logic here is that that integer would basically be a key in a table of files. So basically, again, the file descriptor, the integer itself, would be a key in a hash table with the value being the associated location of the file, kind of something like this. Right? So again, the file descriptor is just the access number or the key associated with whatever file you wanted a handle to. So I want to talk a little bit about some quick caveats about this term file that we use in Unix programming, and that is that really file, it doesn't just refer to, like, when you think of a file, you maybe, for example, think of like, a file where you have some code, or maybe like a word processing file or something like that, right? So file in Unix doesn't just refer to those particular things. It can, but it can also refer to a bunch of other things, such as we've already seen, it can refer to a network connection. It can refer to a pipe between two files, a terminal, and of course an actual normal file, right? So in this case, it can refer to a network connection because a network connection is very much facilitated in the same way that we saw in the illustration earlier, where two processes were communicating using a shared intermediary file. It's just that in this case, with a network connection, we have both of those processes now on separate machines across the network. And now the socket, or the file descriptor, needs to basically perform that communication over the open internet. But other than that, the basic idea still boils down to the same thing as if both of those processes were on the same machine. And indeed, you would basically treat a handle to a socket in the same way you'd basically use a file descriptor for a file on your local machine. And in order to see that, let's look a little bit at some code with which we might actually use in order to send and receive messages through a file. So at the very top, we'd have an include statement to include the socket header so that we could actually initialize a socket, and then we would just initialize a socket using the socket system call, which is then us requesting of the operating system, hey, I want a socket. There are some parameters that would go in the actual socket system call. I've just left them out because it's kind of a lot, and you don't really need to worry about it because you won't actually be making this call yourself. This call will be provided for you in the web server skeleton code. But that will then give us a socket file descriptor. And again, that would just be an integer if you were to actually print it out, because it would just be the key to the actual file or the socket itself. But that's what you would use in order to actually access it. And then once you had access to that, you'd be able to use it to send and receive data using the send and receive RECV system calls. And in this case, both of these would take in very similar parameters. First off, you'd give it the file descriptor for the socket. Response here would be the actual data that you wanted to send along the file descriptor, along the socket. Response length, you also need to tell the send system call the length of the message, and then 0 here is just a flag. And then similarly with receive, it would receive you need to know which socket to receive from. The request here is a buffer that will then hold the incoming message. The request buffer size is the length of that buffer, so that it knows at maximum how large of a message it can receive into the request buffer -1 because of array indexing, and then 0 again being another flag in this case. So that was just a quick illustration of how you might actually initialize and use sockets in order to send and receive messages.